In the conservation of energy experiment, we considered three different sets of conditions that were modeled by word problems. Today's lab on static equilibrium is similar. We have three different static situations, and we want to make measurement of both force, distance, and angle in order to demonstrate that the three conditions of static equilibrium are always met. The three conditions of static equilibrium are the sum of all the forces in the x direction add to zero, the sum of all the forces in the y direction add to zero, and the sum of all the torques about a center of rotation add to zero. The materials for this experiment are a meter stick or yardstick, a spring scale, string, two objects with masses between 100 and 500 grams, a ruler, and a protractor. The first example of static equilibrium is called traffic light. A traffic light is hanging from two wires set at known angles. What is the magnitude of the tensions in each wire? This system does not include the calculation of torques, only vector forces. Here is a physical example of the system. The mass of the hanging object and the two angles are arbitrary. Almost any values are allowed except for a symmetric system with two equal angles. The actual tensions in the two strings are measured with a spring scale, held in a position that doesn't change the two angles or the position of the object. The second system has two painters standing on a scaffold. Two painters with different masses are standing on a scaffold of a certain length and different distances from each end. The cables supporting the scaffold are vertical and attached to each end of the scaffold. What are the tensions in the two cables? The calculation of torque is needed to solve this problem, but all angles are 90 degrees. Also, there are no horizontal forces in this one. Once again, a symmetric system with equal masses, or placing the objects at equal distances from the two ends, is not allowed. The mass of a yardstick purchased at Lowe's is around 155 grams. Here is how the two tensions are measured with the spring scale. The third system is the angled boom. A crate is hanging from a boom set at an angle and held in place by a horizontal cable. What is the tension in the cable? In this physical system, the angle, mass, and hanging point are arbitrarily chosen. This photo shows how to measure the tension in the horizontal string. In the conclusion, compare the measured tensions to the predicted values based on the equations for static equilibrium. The equation for percent error is the percent error is the absolute value of the experimental value and the theoretical value divided by the theoretical value and multiplied by 100.